All right, section 1.4 is on measuring and classifying angles. We have quite a few definitions, so I'm going to go kind of quick through them, and I might draw some pictures on the left side, but by all means, if you need to pause the video, please do so. I just don't want to take up too much of your time by just filling in blanks. So an angle consists of two different rays with the same endpoint. Sides of an angle. In an angle, the rays are called the sides. And the vertex of an angle is the endpoint. So if you take a look over here, that's what an angle will look like. This is the vertex. And then each of these rays are called a side. So the vertex is that endpoint that they share. The measure of an angle is the absolute value of the difference between the real numbers matched to the rays of the angle. So the measure of an angle is always labeled in degrees. This is really the part we need. So and that measure is going to be right here. This is where that measure of the angle is. So in symbols, the measure of an angle ABC will be written like this. We would put M for measure. That's the angle symbol. So measure of angle ABC. An acute angle is an angle that is from 0 degrees up to 90 degrees. So an acute angle will look like this. It would be not open very much. A right angle is an angle that measures exactly 90 degrees. Whoops. So a right angle will look like this. It would have a box like that. It forms a perfect corner, like the corners in rooms are right angles. An obtuse angle is an angle that measures between 90 degrees and 180. And obtuse, you could guess, is more open than a right angle. So acute is small, right angle is 90, obtuse is big. And a straight angle is an angle that measures exactly 180 degrees. So a straight angle actually is a line. It's just a line. Congruent angles are angles with the same measure. And an angle bisector is a ray that divides the angle into two angles that are congruent. Okay, so we have a segment bisector. Now there's an angle bisector. So in example 1, when we're naming angles. When naming an angle, the vertex is always the middle letter. It has to be, or else you name it incorrectly. So if you look at the picture on the right, I'm going to do some highlighting. So let's do blue first. If we take this blue angle, okay, that big angle, that could be called angle ABD. And notice the angle symbol in the front, angle ABD, or we could call it angle DBA. It's the same exact angle. ABD and DBA are the same angles. Notice B is in the middle, but you can flip the order of the outside. Let's change colors. Let's do green. If I take the green angle, the green angle could be angle ABC or angle CBA. Means the same thing. And lastly, I will do yellow. There's a third angle here, this yellow one. This is angle CBD and angle DBC. Okay, those are also, that's the same angle with two different names. When multiple angles share a vertex, you need to have 3 letters. You can't just pick one letter for that. Okay, so what that means is, let's pretend there's another angle down here. And this was angle X, Y, Z. You could call this angle Y, because the only angle with a Y is that one angle on the bottom. So that one could be named with one letter. All right, the protractor postulate basically says that you can measure an angle and it's equal to the absolute value of the difference between the real numbers from OA. So like if we have OA right here and we have OB, the measure of the angle is the difference between this number and this number. So in this case, it'd be, if you look on the inside, it's 0 all the way up to, looks like about 125 or 115. So you can measure an angle using a protractor. So example 2, measure and classify the angles. So angle WRS. So WSR, I read that wrong, WSR. So if you measure that angle, if you look at the numbers, it's 0, 10, 20, 30, 40, 50, 60. So if you check out those numbers, it goes up to about 65. So this would be 65 degrees, and we would call this acute because it's less than 90. Okay, then let's go to green. TSW, so T to S to W, that green angle. So if you look at this, if you start down here, it starts at 0, and now look at the inside. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and then right there is about 115. So this would be 115 degrees, and it's bigger than 90, so that's called obtuse. Obtuse is bigger than 90. Okay, I will go to blue. The blue one is RST. So R to S to T. So that one goes from 0 all the way around to 180. So this angle is 180 degrees. It is a straight angle. Straight angles form lines. So that one forms a line, so we call it a straight angle. And lastly, we have VST. So V to S to T. So that red angle starts at 0, and then 10, 20, 30, 40, 50, 60, 70, 80, 90. So it goes up to 90 degrees, and this would be called a right angle. Because when it equals 90, it's a right angle. Less than 90, acute. More than 90, obtuse. Okay, and then we just have a checkpoint. It says name all the diagrams in the angle at the right. I do want to go through this just because naming angles can be kind of tricky. So first we have this small angle on the right. That one we would call angle HGJ. Or you could call it JGH. We have the smaller angle on the left. That'll be angle FGJ. And lastly, we have the biggest angle, the one that's on the outside. That'll be angle FGH. And just so you know, you could flip the order of the first and last letter and it would still be correct. You just have to keep that middle one the same. Like G has to be in the middle. Okay, and we are going to skip checkpoint 2. And we'll go on to angle addition postulate. So if you look at the picture on the right, it says if A is in the interior of angle WRH. So see how A is in the middle of this angle WRH. So if there's ever a point in the middle there, we can add up the smaller angles. We would say the measure of angle WRA plus the measure of angle ARH is equal to the measure of angle WRH. So what that means is if you take this smaller angle here and the smaller angle on the bottom, that would add up to be the big blue angle. So if angles share a side, you see how the green and the yellow overlap in the middle, then you can add them up to the bigger angle. A shorter way to write this, since these are numbered, like right here, this one's numbered, you could call that angle 1. And the green angle, you could call that angle 2. Okay. So when there's numbers there, it actually makes it easier and to write. It doesn't take as much time when you write. Okay, so how does this work? So there's an example on this. Given the measure of angle GFJ is 155. So G to F to J, this entire angle is 155 degrees. Okay. They give us the two smaller parts. So you see how inside there, change colors, there's this angle and this angle. We can add those two smaller parts up and it's going to equal the big angle. So we would set up like this. We would say 4x plus 4, right? So that yellow part plus the other part, 4x minus 1, is equal to the whole thing, equal to 155. So you take the two pieces, the 4x plus 4 and the 4x minus 1. So now we're solving this. Remember that equal sign kind of splits it in half. So on the left side, let's combine what is 4x plus 4x? 8x. What is 4 minus 1? 3. And it equals 155. From here, we got to get rid of the plus 3, so we subtract it to cancel out. So now we're left with 8x equals 152. And then we want to get x alone. So how do you get rid of the 8? We would divide by 8 to get x equals 19, I believe. So x is 19, which is great, but what do they want us to find? We need to find the measure of angle GFH and HFJ. So go to red. The measure of angle GFH is equal to GFH is 4x plus 4. So now you take 19 and you plug it in. 4 times 19 plus 4. Four times 19 plus 4 is 80 degrees. So GFH is 80 degrees. And I don't know why I can't write over there. All right, and if we want to find the measure of angle HFJ, we would go measure angle HFJ HFJ is right here. So it's 4x minus 1. So we would plug in 19. So it'd be 4 times 19. And this would end up being 75. So the measure of angle HFJ is equal to 75 degrees. So in the end, you find x, you got to plug it back in. Okay. We'll go to the checkpoint just because I want to show another example of this. So it says, given that angle VRS is a right angle, find the measure of angle VRT and the measure of angle TRS. So a right angle, this means that it's 90 degrees. So this angle is 90. So that means the two smaller parts, the x minus 4 and the 3x plus 2, when you put them together, x minus 4 plus 3x plus 2 is going to be equal to 90 degrees. So we go through and solve that. On the left side, we have an x and a 3x. Combine those to get 4x. We have a negative 4 and a plus 2. Combine that, we would get minus 2. Now we got to get x alone. So we add 2 to get 4x equals 92. And then we divide by 4. When you divide by 4, we would get x equals 23. Okay, and then when we're done, we have to find VRT and TRS. So the measure of angle VRT is equal to x minus 4, and the measure of angle TRS is equal to 3x plus 2. And now we just have to plug x in. So it would be 23 minus 4, which is 19. And it's 3 times 23 plus 2. 3 times 23 plus 2 is 71 degrees. So we get 19 degrees and 71 degrees. That would add up to 90. Example 4, identify the congruent angles. It says identify all pairs of congruent angles in the diagram. So if you look at the picture, congruent angles have the same number of arcs. So do you see how this angle and this angle both have 2 arcs? So we would say that angle L is congruent to angle M. And we can use one letter because there's only one angle that has a vertex of L. Okay, and the other angles that are congruent are down here. Those arcs, those little arcs, mean that they are congruent to each other. So we could say angle P is congruent to angle N. And this works because there's only one angle P and one angle N. Okay, another way you could write this, I'm going to put or. You could say angle MLP is congruent to angle LMN. This is the same thing, but what's in the red is fine. Okay, and then it says if the measure of angle P is 120, so if this is 120 degrees, what is the measure of angle N? Well, angle N would have to equal 120 because angle P is congruent to angle N, which means they are the same measure. And then we have example 5. I think it's our last example. It says, in the diagram at the right, ray WY bisects angle XWZ, and the measure of angle XWY is 29. Find the measure of angle XWZ. So it looks like we have to draw a picture. So if we have angle XWZ, so I'm going to draw this angle. X, W, Z. And they say that ray WY, so W to Y, bisects that. Find angle XWZ. And they tell us that XWY, so X to W, X to W to Y, they're saying that angle is 29 degrees. So let's talk about this. If it's bisected, bisected means it cuts it in half. So that means that this side and this side are equal. So this other angle is 29 degrees as well. So how big is it for angle, the measure of XWZ? So the measure of XWZ is equal to 29 plus 29. So XWZ is 58 degrees. Okay, and if you want to stop right now, you can. I'm going to just run through the checkpoints quick so you can see a couple examples, and that'll be all. Identify all pairs of congruent angles. So in this one, angle B is congruent to angle D, and angle A congruent to angle C. And then if the measure of angle B is 135, how big is angle D? The measure of angle D is equal to 135 degrees as well. And then last one, in the diagram below, KM bisects angle LKN. So it means it cuts it in half. And they say that LKM is 78. Find angle LKN. Well, if this side's 78, the other side has to be 78 because it is bisected. So we would say the measure of angle LKN is equal to 78 plus 78. So 78 plus 78 is 156 degrees.